Hey, how you doing? Today I'm going to take a look, if I can get settled in here, I'm going to take a look at MIG welding, which would be short arc, spray transfer, and pulse arc primarily. There is, globular mode for MIG as a mode of transfer, but it's not something that you wouldn't do like globular MIG for any real reason. As far as modes of transfer are concerned, to really understand what's going on, I would definitely recommend just going onto YouTube and doing a search for, high-speed video of short circuit transfer, spray transfer. You can find, I think there's one called rotational spray, and pulse spray, and then of course globular as well. There's some high-speed footage out there that's I don't even have the capability to produce, super high speed. But you can see what those modes of transfer look like, and we'll see that to a tiny extent here. But I'm pretty limited as to what I can film in terms of quality. But you can hear that transfer mode change, and you'll see that in the weld itself when you're welding. You'll see that certainly in the amount of penetration that you're getting. But basically at its core, MIG welding is, we've got a MIG gun, I've got, this is a big old 400 amp Bernard gun, way bigger than I need here in the high school. I'm running off of a Miller XMT 350 MPa power supply. That power supply, if I can turn my camera without totally messing everything up here, is right here. I've got the S74 MPa Plus wire feeder, and of course the power supply down below. Back around. All right. Now, that having been said, I've got, what I would call more or less state-of-the-art equipment here. That doesn't mean that you need that to do MIG welding. You can run MIG off your basic 220 plug-in machine at home with all the modes of transfer except for pulse arc, and certainly with, well, I guess if you got the right equipment you could, right? You could spend, $7,000 on a Miller and run it off 220 single phase. But the homeowner, the average person, is not going to need that. At my house, personally, when I'm welding, if I'm doing anything with MIG, basically if it's, certainly 1/8 inch and under, I'm running short arc, short circuit transfer. I'm probably going to be welding with 023, 025 wire, maybe 030, 035, but certainly not 045. And today, I run the machine right now, I've got 045 wire set up. If I'm doing spray transfer, I'm welding on materials that are thicker, typically than obviously 1/8. Usually kind of 1/4 inch and up. There's a kind of a no man's land, in between there, where spray's a little hot, MIG's a little cold. But again, you can run MIG hot. Jody at weldingtipsandtricks.com, he's got an outstanding video on spray transfer versus MIG welding. He runs 035 wire, cuts them, does the macro sections, and it's awesome. His work is amazing. So check that out. But for an intro today, I just want to talk about, and this is really, again, for the students here at the school, right? That's the purpose of these videos. I'm not a monetized channel trying to make money. But for the students, they need to understand those basic modes of transfer. And you can start off with almost any wire diameter. The reason I'm starting with 045 is because I'm going to run 045 wire in the various modes. Now, I will lower the wire feed speed and essentially get a globular transfer just so you can see it. I would never weld like that. Let's just make that clear. But I want to show short circuit transfer. I'll also turn this up, hot, so you can see that it still works, right? It's hotter, but it's still short circuiting. Then we'll switch shielding gas and we'll get a spray transfer. And there's a noticeable difference between there. Then I'm going to go one step further, and I'm going to put on a roll of 045 70C6 metal core. Now, I love metal core wire for MIG welding. I would not run solid wire MIG welding unless I had to. if metal core was an option on materials, say 1/4 inch and up. Now on the thinner materials, the solid wire works great with short circuit, but if you're going to be running spray transfer, you really should look into metal core electrode. It runs just substantially smoother. There's so much less spatter. You can basically weld almost as easily as you can weld with pulsar. So you can weld certainly vertical up, although that's hard depending on the material thickness. But you can run vertical down and get penetration, although there's special techniques and considerations that have to be taken for any vertical down welding on structural thicknesses. And you can easily weld overhead. But just for flat welding, if you're working at home and you're rolling stuff around and you're welding it up, making it easy, it's metal core is definitely worth considering. Now, I've got metal core wire here at the school in 045 diameter only, and I've only welded at Bath Iron Works. I mean, my experience is very limited. I have a lot of experience, but it's all at the shipyard for what that's worth, okay? So I don't even know if they make 035 metal core. I'm sure somebody does, you know, why wouldn't they, you know? But certainly 045 metal core is going to run smoother in spray transfer than 030, 035, or 045. It's magic, but it really works. So without any further ado, let's start off with short circuit transfer. Now I'm running C25 gas, 7525 argon CO2. All right, now short circuit transfer, like all other forms of really MIG welding, with the exception of spray and pulse in some circumstances, what you're looking for is that constant crackle, that constant high-speed sizzle, bacon sizzling sound. In order to get that, the wire feed speed has to be adjusted just right. Now I'm at 175 inches per minute with roughly 19 volts, a little over 19 volts. I'm going to turn the wire speed down and force this into what's called a globular transfer. And hopefully the camera will pick this up and we'll be able to see what this globule looks like. Now I'm going to drop this way more than I need to, just so to really show that globular transfer. But essentially short arc is a series of arc starts and stops. So the arc is starting and going out and starting and going out and starting and going out. It's doing it very rapidly. So you're going to see that transition on high speed. You won't see it with your naked eye. But I'm going to drop this about 20 inches per minute, and I'm going to keep going down until we get to a real globular transfer. So I'm at 175, I'll drop it to 155, and we'll weld this. Here we go. Again, that rate of transfer is slower. You can see on camera here, on the other camera, there's just it's a laughable amount of spatter. You would never ever do this. Again, that is a little more aggressive in terms of the crackle. You could see, at least I could see, I got to review this camera footage, almost a globular start. It really wants to ball up. I'm going to go to 105. Here we go. Almost there, okay? I'm going to drop down again to 85. All right, I'm gonna take a look at that and see how that came out. And if it didn't come out good, I guess I'll delete it and you'll never know the difference. Now, I'm gonna go back up to my original setting at 19 volts, and I'm gonna get the wire feed speed set back up. I'm still at 19 volts, but I'm gonna turn the wire speed back up to 175, and I'm just gonna kind of review this. And then what I'm gonna do is I'm gonna go up about 2 volts at a time and just tune this in until we get up to, say, 25 volts, at which point this is just going to be awful with C25 gas. From there, we'll switch over to spray transfer, and we'll do that by changing the gas. That's all we're going to switch. We may have to, tune the machine in a little bit, but we'll switch that over. And then again, we'll look at metal core. So right now, let's just tune this in. And again, the process of tuning this in is really just listening for that constant, nice, rapid sizzle. How much crackle you get really is up to you. I would definitely do fillet break tests and just make sure that you're getting penetration. Look carefully at the toes of your weld. You can use your phone, you can zoom in. On my old Samsung, I can zoom in up to 8x. Use it as a magnifying glass, especially for people like me with bad eyesight. These are reading glasses, it is what it is. So that's what I would do, but I'm going to tune this in and we'll kind of just go back through and we'll see what this sounds like at different voltages. Okay? Okay, that's not the end of the world. Let's go up to 23 volts. So again, it's going to get nasty. The crackle rate that I really want is a little faster. But God, I can't imagine how much worse it would weld if I turn that wire speed up much more. But we're going to go to 25 volts, okay, just as a jump here. I'm going to go up to 265. Actually, I'll just go to 270. Okay, and I'm going to try this out. Now from here, we're going to switch over the gas, and you're going to see a remarkable difference in smoothness. But this is 25 volts, 270 inches per minute. Excuse me, get the hiccups, God knows why. Short arc, right? This is short arc. All right, now that's just a horrible, awful thing. From this point, I'm going to leave it at 25 volts. I'm going to turn the wire speed up to 300 and just see if I can increase the rate of that crackle. So, let's leave that right there for a second. You can't even see. So this is 95.5 argon CO2. The other bottle is 75.25. So the only thing I did was switch the gas, okay? That is the only difference. So I'm going to switch over. I'm going to purge some of this gas out through just to get this line cleared. It doesn't take much. I'm connected directly to it. And without doing anything else, I'm just going to, let me back up. I will probably have to tune this in to get it running ideally, but without doing anything else, we're going to just run with just a different gas type, okay? Again, 300 inches per minute, 25 volts, 25.2, 25 point, whatever. This should be much smoother. Okay. That's spray transfer. Okay. Let's take a look at this again. I'm going to weld another section here. I got limited focal distance on my camera here. Here we go. Spray transfer. You can see the weld bead itself is just wicked smooth. Alright, so right now I'm switched over to Pulsar. This is a program on the Miller machine, approximating about 19 volts. Alright, so that's pulse. When people say MIG, they mean, generically they mean short arc. Okay, if you're watching a TV show and they're building, motorcycles or cars or whatever they're fabbing, you hear a lot of crackle, they're running short arc. Okay, heavy industry does not run short arc. Heavy industry runs spray transfer MIG for the most part. If they're running MIG, it's spray transfer. Metal core electrode, which I'll cover. The last thing I'll show you is metal core, but for right now, just switching over from the solid wire, 045 wire, which again, we would not run 045 wire at 19 volts unless we had to. I would run 035, 030, 023 on thin material. But again, to demonstrate the process with 045 wire, we started off with short circuit transfer. I lowered the wire feed speed until we got a real globular transfer, and at 175 inches per minute we had a pretty decent short arc transfer mode, relatively rapid, crackle, pretty aggressive, sounded good. At 135 inches per minute or 105, wherever we ended up with, I can't even remember now. At the low end, when we get that globular drip, 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 you can kind of see what's happening. Essentially, that wire is melting back, and then the arc goes out, for just a split second. But of course, the wire is still feeding, so the gap is closed, and then it reinitiates. And every time you hear that pop, 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 that's the arc starting back up. We could turn that up wicked hot. It will still crackle. You will get tons of penetration, but the cost is spatter. With pulse arc, as you can see in this last little clip right here, even at 100 inches per minute, 19 volts, it's spatter free. I mean, it's basically spatter free. It's not to say that it is in all cases. If you're welding over a mill scale, and I did not clean this last plate, we just welded on it. But it is basically a spray transfer that's virtually spatter free. In order to get that spray transfer, we have to have a high argon gas content, and that gas content in this case is 95%, the remainder being CO2. Again, anything with 90 plus will work, but 95.5 to me is what I would call ideal, because it's what I'm used to, right? I worked at the shipyard. All right, so this is the Bowler Diamond Spark 46 MC metal core wire. It's friggin' awesome. It's a seamless wire, and so it'll store for a long time. The seamless wire is better in general for flux core, especially where you might get moisture inside. But it is metal core wire. It's copper coated. A lot of metal core wire isn't. It's black like flux core wire typically is. But this is what I use at the shop because I friggin' love it. All right, here we go. That just runs awesome. All right, first up is short arc. I'm at right now 24.2 volts, 24.4 on the power supply, 24.2 it says on the feeder, what it's worth. 300 inches per minute wire feed speed. This is C25 gas short circuit transfer. Okay, so again, this is the same wire feed speed, 045 70S6, solid wire, 95.5 gas, argon CO2, pulsar, okay? Now you don't really see the true benefits of pulse arc until you're welding out of position, but already that's smoother. The arc is more stable. It is, it's not as crackly. There's less spatter. Again, that's the advantage of pulse. Now the last section on here, I'm going to weld with metal core. I got to switch the wire over, so I will do that right now. It's still 0.45 diameter. And so far I haven't actually turned any knobs. The machine is still the same. Although the program voltage, I'll use air quotes around voltage, it can be displayed as either an arc length or approximate voltage, is higher with pulse, but that having been said, 300 inches per minute is the wire feed that we're going to be running for all of it. All right, so I've got my metal core wire on. Again, I'm still at 300 inches per minute. I'm going to switch this over to MIG mode again, not pulse arc. I'm still on 95.5 gas. And let's see what the metal core runs like. Again, spray transfer MIG. It is so buttery smooth. I don't know what would possess anyone who is running spray transfer MIG to run anything other than metal core electrode. It is friggin' awesome, okay? Now, I'll look at the details behind these and get some good weld video footage of these processes in other videos. But for right now, basically recognize that there are different modes of transfer for MIG. So when you say MIG welding, it really leaves a lot open. Is it short arc? Is it spray arc? Is it pulse arc? And again, are we running solid wire or core electrodes? You can run pulse arc with metal core as well, and the heat input reduction is phenomenal. The control that you have with it, vertical up, vertical down, is just out of this world. But that's it for today. We'll look at those various modes of transfer and how to set these things up. The short version of it is that the only real difference between short circuit transfer and spray transfer is the shielding gas, and to some degree the voltage, right? You still need a reasonable amount of voltage, although I can get metal core to spray at much lower voltages than I can get 045 solid wire to spray. But again, we'll look at that in a separate video.